Okay, in this video we're going to talk about determining joint, marginal, and conditional probabilities. So conditional probability is when the probability of an event is influenced by whether a related event has already occurred. So it's written like this, and this is read the probability of A given B. So what we're interested in calculating is this event A, but given something else has happened. So let's go through an example to show how this is calculated, what it means. This is the equation right here for conditional probability. So the probability of A given B is equal to the probability of A and B divided by the probability of B. So I'm actually going to show you an example, again, to make sense of this equation. So let's give an example. So say we're looking at police officers and whether police officer is male or female. Sorry, I don't know why I wrote male and women. And so in this video, what we're going to better understand is that if you get a promotion, right, does it depend on whether you are male or female? So it'd be nice if you get a promotion and you have a probability of promotion. It doesn't depend on whether you are male or female. So in this example, we're looking to see whether the probability of you getting a promotion or the probability of someone getting a promotion depends on whether they are male or female. So that is what conditional probabilities tell us. They tell us the probability of an event happening given other information. So that's the example. So we have 1,200 police officers, 960 are male, the rest are female. 324 received promotions, and of those, 280 were male and only 36 were female. So you might look at this and think that, well, gosh, so many more were males. Look at that. That's unfair, right? There are only 36 females, but, well, hang on. Let's look at the distribution here. There's a lot more males than females. So at surface, it's kind of hard to figure out, right, if there's a difference between getting a promotion, depending on whether or not you're male or female or not. So that's what conditional probabilities will tell us. So we have to calculate these. So we want to calculate two probabilities, and then we can compare them to see, if there might be some type of discrimination going on here is ultimately what the question is. So we have to calculate these two probabilities, the probability of promotion given the officer is female and probability of promotion given the officer is male. So here's the data in a table. So, right, we have the male, right, here's 288 that, of the men that were promoted, the rest were not promoted, so this is the total number of men. We can check that, right, there were 960 men. For women, there were 36 that were promoted, 204 that were not, out of a total of 240, right? We have 240 women, 36 were females that were promoted, right? And then we can just add these together to find out that there were 324 people that were promoted, right? 324 people received promotion, and so on, right? Total samples 1,200. Here's the total number of males, females. So we have all the information. So what we can do is we can start turning these raw numbers, right, the frequencies, into probabilities. Specifically, we can look at joint and marginal probabilities. So what does joint mean? Joint means together. So the joint probabilities are in the middle of the table because they're telling us the probability of two events happening. So in this cell right here, 0.24 is equal to the probability that you are a male, or an officer is a male and gets promoted. Where did this number come from? Well, right, just 288 divided by 1,200, right, is going to give us, right, that percentage, if you will. So there's 24% that were men and were promoted. Not promoted in male, right, you get this, right, just by dividing 672 by 1,200. Over here, right, in the margin of the table, right, we'd want to know, for the total, right, so we just divided 324 divided by 1,200 would give us 0.27. So that's just the probability of promotion, right, the percentage, right, the relative frequency of people that got promoted, not promoted, right, and you can just calculate all these just by simple division. So again, the probabilities in the middle of the table are called joint probabilities because they're telling us the probability of two events happening together, right, women and not promoted, right? This one, 0.03, is women and promoted, and so on. On the outside, right, or in the margins of the table, we have the marginal probabilities, and they are called the marginal probabilities because they appear in the margin of the table. So for example, like I said, this joint probability is the probability that the officer is male and got promoted. This right here, 0.20, is the probability that the officer is a woman. Right, 20% chance compared to 80% chance. So why are we using these? Well, because eventually you'll see we use the joint and marginal probabilities to calculate the conditional probabilities. So let's just go through this example, and let's first calculate the probability of a promotion given the officer is male. Right, so we already kind of figured out this probability in terms of just understanding. Or excuse me, we didn't calculate this one, we're going to. So what is the probability of promotion given the officer is male? So we're going to live right now in this realm of just looking at men. So if I just said, forget about men and women, I just said, hey, what are the chances that you get promoted? Right, you would just divide, right, promotion divided by total, 288 by 960, right? And that's exactly what we do here, right? So right now we're just focusing on men, irrespective of women and anything else, right? The probability of promotion, right, given that you are a male, right, because we're just living in the male realm right now, we just divide 288 by 960 to get 0.30. So there's a 30% chance of getting a promotion given the officer is male. So we can use, like I said before, so remember, we just calculated that with the raw data, but we can use the joint and marginal probabilities to calculate the conditional probabilities. I had already said that before. So let's start tinkering with this. So let's divide, just for fun, both the numerator and the denominator by 1,200, right? The total number of officers in the study. 288 divided by 1,200, this 960 from up here divided by 1,200, right? We would get 0.24 divided by 0.80 is 0.30. That's the answer. So basically what this is showing is that if we divide, right, these numbers here by the total sample, right, we're still going to get the same number that we already calculated here, which is, right, this conditional probability. Well, these numbers should look familiar, 0.24 and 0.80, right, because they're right here. Those are the actual, right, the joint and the marginal probabilities, because I said you can use the joint and marginal probabilities to calculate the conditional, and that's exactly what happens right here. So let's put this together. The equation that I just wrote for you up there, right, 288 divided by 960, right, is going to give you 0.30, but if you also just divide by 1,200, right, you're going to get 0.24 divided by 0.80, right? This is just the joint and the marginal probabilities, right? So let's just kind of substitute, right, equations. So, right, the probability of A given M is equal to this joint probability divided by the marginal probability, right, the probability that you're male. The joint is a probability that you're male and you got promoted, right? That is where, right, remember this original equation I showed you? That's where it comes from, right? So you got the joint probability divided by the marginal probability. So that's just an example to show you, how to calculate conditional probabilities, where this equation comes from, how conditional probabilities are related to or can be calculated from both joint and marginal probabilities. I showed you how to calculate joint and marginal probabilities and what they are. So let's actually continue with our example. So we now know the conditional probability, the probability that you get promoted given you are male. So let's repeat this for females, because remember, we want to compare them to see if there's possible discrimination, right? So the probability that you get promoted given you're a woman is equal to the joint probability that you're a woman and get promoted, right? Let's go back to our table. What is it? The joint probability, right? The probability that you're a woman and you get promoted is 0.03, right? Divided by the marginal probability, the probability that you're female, that you're a woman, is 0.2, right? And divide those together and you get 0.15. So basically what this is saying is that the probability of a promotion given the officer is male is 0.30, which is twice the probability of promotion given the officer is female, right? Because the conditional probability here is 0.15. 0.15. Is that what I said? So basically this would be a case for possible discrimination, right? It's not a proof, meaning yes, there is. It's just some statistics, some support that there might be something going on here. So I hope this makes sense. In the next video, we're going to start talking about independent events.